part of the AP Calculus curriculum is also deriving inverse trig functions, another topic from pre-calculus. So if we recall from pre-calculus, the inverse trig functions on the calculator will look like this: inverse sine of x, inverse cosine of x, and inverse tangent of x. It has the -1 exponent after the third letter of the trig function. We also have the inverse trigs of secant, cosecant, cotangent. You don't have to worry about those for the exam. Only these three are on, have the potential to be on the exam. All three of them won't be, but one of them will. The -1 exponent can become confusing. If we jump quickly down to the fourth bullet point, we like that -1 x, that inverse button. We know that x to the -1 is equal to 1 over x. So quite often, when students see this inverse sine function, they think it's the same as 1 over sine. And that's not true. All right. This is not inverse sine. This is the reciprocal of sine, and we know the reciprocal of sine is actually cosecant. So you would use this notation to graph the cosecant graph. If you want inverse sine, you have to use the second sine button on the calculator in order to get the inverse sine. Right. So in order to sort of alleviate that confusion, another way of looking at inverse trig functions is not with the -1 exponent, but rather with the ARC, or the arc prefix. So arc sine, arc cosine, and arc tangent. Those are the exact same things as the inverse. It's just another way of writing it, another way of saying it. The AP exam uses both of them, so just be prepared to see either arctan or also inverse tan. They mean the same thing. But again, just keep in mind they're not the same thing as the reciprocals of sine, cosine, and tangent. You already know what those three are. Okay. So what are the graphs looking like? Well, we know that the graphs of the inverse functions are reciprocals over the y equals x line. So if I draw a quick graph of the sine of x up here, all right, there's my axes, and I know that sine is a wave function which goes on and on and on, like so. And if we were to reciprocate that, or rather to reflect that over the y equals x line, which is this line right here, right, what ends up happening is we have a wave function which is now vertical. So it looks like so. Okay. And the issue here is that this function obviously fails the vertical line test, and therefore it's not a function. It's just a relation. So the way that we get around that is we restrict the domain of the inverse sine, and the same thing happens with inverse cosine. So in regards to inverse sine, our domain is only from x equals -1 to x equals 1. And same thing with inverse cosine. -1 to 1 is our domain. Inverse sine's range goes from -pi/2, which is right here, about -1.5, up to 1.5, which is pi/2. Cosine's range goes from 0 up to pi. All right. These restrictions don't apply to inverse tangent, because if we think about the tangent graph, okay, the tangent graph, we had a whole bunch of those. But if we just focus on the one in the middle, this one right here, and we reflect that over the y equals x line, we get a curve that looks kind of like the cube root of x. And this curve actually will not fail the vertical line test, so there is no restriction on the domain. The domain is from -infinity to infinity. The range will always be between pi/2 and -pi/2. All right, we're never going to get outside of those two values. This will never reach 2. Because, again, we know from regular tangent that the domain was -pi/2 to pi/2 without including, non-inclusive, so it doesn't include the endpoints there. And that's the same thing with the inverse tangent. So because we have these three curves here, the fact of the matter is we can still draw tangent lines to these curves wherever we'd like. Okay, as we do right here. And if we can draw tangent lines, then those tangent lines have slopes, and therefore if we have the slope of the tangent to the curve at a point, we have a derivative. So these three functions, these inverse trig functions, can all be derived. And the next video is going to show you how we come up with their derivatives.